Hello guys, welcome back to another lecture in this course. In this video, we shall be looking into gradient descent. So gradient descent is an optimization algorithm which is commonly used to train machine learning models and neural networks. And the training data, it helps these models learn over time, and the cost function within gradient descent specifically acts as a gauging in its accuracy with each iteration of parameter. Hence it updates until the function is close to or equal to 0. The model will continue to adjust its parameter to yield the smallest possible error. So it is very good, especially if you optimize well your model. It is very powerful for artificial intelligence. And we have also what we call a learning rate, the rate in which your model is learning. And it is the size of the steps that are taken to reach the minimum or the minima. It is evaluated and updated based on the behavior of the cost function. And the cost function or the loss function, it measures the difference or error between the actual y and the predicted y at its current position. And the idea of gradient descent is to take repeated steps in the opposite direction of the gradient of a function at the current point. For example, we are having a gradient descent on a Cartesian plane or on a graph. Assuming this is our graph, we're having a function where y is equals to f of x, that we can see here. Y is equals to f of x, and this is a linear line, and this is our minimal point, where on our minimal point we are having coordinates x and y, the x coordinate and the y coordinate. And we are saying gradient descent, we are moving on an opposite direction by a learning rate. Let's say, assuming x here, maybe this is the point x, where x is 6. So we are moving with a learning rate going backward until we reach a minimal point, this point. So this movement backward, or the steps on the opposite direction of a gradient, it is how the model is learning. So this slope can be found by using our derivative, the concept that we were learning on our previous lesson of differentiation. So it's just dy dx of our first derivative of this function here, of this function. Right, let us take a look into a practical concept of gradient descent, assuming that we are having a function f of x equals to x squared minus 4x plus 5. And remember where y is equals to f of x. So we can plot a graph having maybe constants. Let x equals to, we can start from a negative side. So let us say let x is equals to minus 2, minus 1, 0, 1, 2, 3, 4, and going forward. So it means by substituting these values, then f of x, meaning the y value here, will be equals to maybe 17, 10, 5, 2, 1, 2, 5, on and on. Okay, these are the assumed values that we are having. So after assuming these values, let us plot a graph. So if we are to plot a graph, assuming this is the graph that we are having on a vector space or on a dimensional space, where this is our x-axis, this is our y-axis. Let us assume that the graph is coming, it reaches here, and it turns here. Okay, this is f of x is equals to y. Okay, now let us assume this point here, let us call it 5, and let us say this point is 6, and this point is 7. Let us call this point 5, just like that. This is our point 0. If we are doing application for the gradient descent, let us apply application of gradient descent. The application for gradient descent, what we need first, we need to have a gradient. And how do we find the gradient? We use the first derivative. And first derivative, it's just dy dx here, which is nothing but 2x minus 4 of our function. And our function here, our function that we are having is f of x is equals to x squared minus 4x plus 5, where 5 is our constant here that we are seeing here. So we are saying that this is our gradient. So if we are having a gradient, we need to perform gradient descent by starting from a random, let us say a random number. So let us start from a random number. Let us say x is equals to 6. So we are going to perform gradient descent from 6 here. We are going to start at this point to do gradient descent. So let us now move in the direction of the negative of the gradient. And the question now we have to ask ourselves is at what pace? If you are moving on the opposite direction of our gradient descent, obviously we are going this way. But at what pace? Which rate are we going to move on the opposite direction of our gradient? Then it means we need a learning rate. Learning rate for our model. Learning rate. So learning rate now we are going to use, let us use 0.1. We can use 0.01, it depends with the rate that you want to depict your model in machine learning to learn with. Let us perform our iteration for the gradient descent. So let us say iteration of gradient descent. So remember we say we initialize our value as let x is equals to 6, and also our learning rate, let's say underscore rate is equals to 0.1, and also our gradient dy dx is equals to 2x minus 4 for our first derivative. Now to perform iteration, let us do our first iteration. Let's say hash iteration 1. So the iteration 1 that we are going to do, we are going to say, let's say create a variable gradient underscore descent is equals to x minus, that's the formula for gradient descent, minus our learning rate, learning underscore rate, times our gradient, which is dy dx, which is nothing but 6, our constant, our random variable that we choose. We are going to start at 6, subtract our learning rate, which is 0.1, times the gradient, which is 2, times x, which is 6, minus 4. After computing, we get 6 minus 0.1 times 8, which is nothing but 5.2. That's our first iteration. So once we iterate here, it means our gradient, on our gradient descent, we are moving from 0.6 with a step of 5.2. So we are going on 5.2 on our, then we do another second iteration. Let us say second iteration hash iteration 2. So on our second iteration now, it means x is equals to 5.2 now. So what we can do now is our variable gradient descent 2 is equals to x minus our learning rate, learning underscore rate, times our gradient, which is nothing but 5.2 minus 0.1 our learning rate, multiplied by bracket of 2 times x, which is 5.2 minus 4, and which gives us nothing but 5.2 minus 0.1 times 6.4. And if we compute this, we get 5.2 minus 0.64. And finally, we have 4.56. So it means here also, this is the next value. So it means we move this way again until we reach at this point. So assuming this was 2, so we move here to 5.2, then we move say 4.56, and we move until we reach to this point. So this is the learning rate in which our model is learning the given data. So I think this is all for this lesson. Thank you for watching. Bye-bye.